Inspem. Beliau yang saya maksudkan adalah Dr. Benjamin Yusof. Sebelum beliau membentangkan pembentangan beliau pada petang ini, saya akan kenalkan sedikitlah latar belakang mengenai beliau. Dr. Benjamin Yusof merupakan penyidik pasca kedoktoran di Laboratory Kriptografi, Analisis dan Struktur. Beliau juga merupakan pensyarah kanan di Universiti Malaysia Terengganu, dan beliau mendapat pendidikan jasa pertama dan master dari UMT dan PhD dari University of Barcelona. Bidang kepakaran beliau adalah fuzzy set dan result analysis. Pada hari ini beliau akan membentangkan pembentangan beliau yang bertajuk Circular Q-Rang Octopair Fuzzy Set. Tanpa melengah masa, saya serahkan pada Dr. Benjamin. Yang somaknya silakan.
Okey, saya terima kasih kepada Dr. Rohaizat. Okay, Assalamualaikum and good afternoon to everyone. So thank you for joining this session. Okay, so first of all, let me share my screen. Okay. Full screen. Okay, Dr. Rohaizat boleh tengok kan? Boleh nampak?
Ya, boleh.
Okay. Okay, so Bismillahirrahmanirrahim. Thank you again to Dr. Rohaizat as a chairperson for today's session, and to everyone who joining this session. As mentioned, my name is Benjamin Yusof from Universiti Malaysia Terengganu. I'm under the Faculty of Ocean Engineering Technology and Informatics, especially under the Special Interest Group on Modeling and Data Analytics, SIMDA. Okay, and at the same time, currently I'm doing my postdoctoral study in Inspem, Institute for Mathematical Research, under the supervision of Prof. Adam Kilicman and also Associate Prof. Dr. Nur Fadlina Muhammad Sharif. Okay, and for today's presentation, this is a joint work with Prof. Adam and as well as Dian Pratama, my PhD student. Okay, and this topic also I was presented actually a couple of days ago in ICMS, International Conference of Mathematical Sciences. Okay, so today I just made some changing to the slide in order to, I think, to make it more general, okay, not focusing specifically on the theoretical part. Okay, so let's begin with Q-Rang orthopair fuzzy set. Okay, so this is the outline of my presentation, which consists of the following items, and maybe I just focus only on 2 points, which are circular Q-Rang orthopair fuzzy set, so the idea behind that, and also relations and operations of a circular Q-Rang orthopair fuzzy set. Okay, so let's begin with a general introduction, okay, historical concept behind this idea. Okay, so in general, we focus on uncertainty quantification. So you can see that nowadays uncertainty quantification is quite popular. Actually, just a new term that used to represent 2 kind of thing. Okay, so the first one, aleatory uncertainty, and the other one, epistemic uncertainty. So aleatory uncertainty basically more popular to the economic department, business, for example. It is based on stochastic or irreducible uncertainty. So basically, aleatory uncertainty deal with chances or random variables concept. Okay, so while epistemic uncertainty, it is a systematic or reducible uncertainty. It is deal with incomplete, inadequate, or imprecise knowledge. Okay, so we can make the difference between the two. For aleatory uncertainty, so we have, as I mentioned before, probabilistic approach and epistemic non-probabilistic approach. Okay, and of course for probabilistic approach, we have probability theory, the most general one, the classical concept to deal with uncertainty. And for non-probabilistic approach, we have fuzzy set theory, possibility theory, and of course the higher order fuzzy set, the extension of fuzzy set. And in between this concept, so we have the combination between the two. For example, probability theory integrate with possibility theory, and then we have evidence theory. Okay, for example, Dempster-Shafer theory of evidence. Okay, just to highlight the general idea, the big picture of the main topic that I will discuss today. And of course, I will focus on fuzzy set theory, especially the higher order fuzzy set or intuitionistic fuzzy set. Okay. So before that, let's look at the idea toward the introduction of fuzzy set theory. So we know that fuzzy set theory is the theory that expand the classical law, okay, which are law of non-contradiction, which is A intersection A complement, okay, so should be null, okay, and law of excluded middle, A union A complement should be X, okay. So that's the classical logic or classical set that maybe proposed long time ago, the classical mathematics by Aristotle, okay, at that time. And then beyond this, there are some other researchers that propose actually this law should be something in between. Okay, there should be not membership and non-membership, not only membership and non-membership. It should be something in between. Okay, so that's the idea of toward the introduction of fuzzy set theory. Of course, we can look at Brouwer in 1912, so proposed the idea of intuitionism, where try to expand beyond these two laws. Okay, and then Russell, a philosopher, proposed the idea of vagueness, and then Lukasiewicz, mathematician, come up with three-valued logic. Okay, so we can see that their three-valued logic represent membership, represent truth, false, and as well as uncertainty. Okay, there exists another element, uncertainty in there. And then Black in 1937 also proposed the idea of vagueness. Okay, so Black as well was a philosopher, okay, and he not formalized the idea in mathematical way. Okay, so that's why this idea, okay, proposed by Zadeh in 1965 by providing the mathematical concrete behind that. Okay, before that, before Zadeh, of course, Lukasiewicz in 1956 just extended the idea of three-valued logic to multi-valued logic. Okay, so that's the idea of fuzzy set theory. We deal with imprecise knowledge. Okay, and then of course intuitionism based on logic, and then later on uh, extended using the fuzzy set concept, and then come up with intuitionistic fuzzy set, okay, by Atanasov in 1983, okay, in the proposal that he published in Proceeding, and later on published in Journal in 1986. Okay, and for now, intuitionistic fuzzy set consists of membership, non-membership, and also hesitancy degree in between. Okay, and we call this intuitionistic fuzzy set as non-standard fuzzy set later on. Okay, so before I move to Q-rank autopay fuzzy set, so we look at the limitation of intuitionistic fuzzy set and why we propose circular Q-rank autopay fuzzy set. Okay. Okay, so intuitionistic fuzzy set was developed to handle problems related to imprecise and incomplete information. Okay, like I mentioned before, so it is a generalization of fuzzy set, where fuzzy set we just have membership and non-membership. Okay, we can quantify imprecision of knowledge, while intuitionistic fuzzy set we allow incomplete information. So meaning that between membership and membership, there exists something we call hesitancy degree or incomplete information. Okay, and of course, intuitionistic fuzzy set provide more flexible and covers more uncertain events, and it met the condition of mu plus nu less than or equal to 1. Okay, so membership mu and nu, non-membership, can be allowed to be less than or equal to 1. So meaning that we release the strict constraint of fuzzy set, where mu plus nu should be equal to 1. Okay, however, to cater the issue that beyond this inequality, where mu plus nu greater than 1, so several extension of intuitionistic fuzzy set have been proposed later on. Okay, for example, intuitionistic fuzzy set of second type. Okay, so Atanasov in 1993, and then intuitionistic fuzzy set of P type by Vasilev, Atanasov, uh, and the rest, 2008. And then Pythagorean fuzzy set, which is similar to intuitionistic fuzzy set of second type. So I will explain later. It proposed by Jaeger in 2013. And then Fermatian fuzzy set by Senapati and Jaeger 2020. And then generalized autopair fuzzy set proposed by Jaeger in 2017. And Q-rank autopair fuzzy set as well. Okay, so basically generalized autopair fuzzy set is Q-rank autopair fuzzy set that was proposed in 2017. Okay, so all these sets known as non-standard fuzzy set because we allow some degree of hesitancy in between. But we can see that all these set based on Chris membership degree. Okay, so remember we have x-axis to represent any element of set, and y-axis represent the degree between 0 and 1 fuzzy value. Okay, that fuzzy value between 0 and 1 in all these set based on Chris membership degrees. Okay, and then come up with the idea of interval valued fuzzy set. Interval value intuitionist fuzzy set where it expanded from a singular point, okay, into an area in intuitionistic fuzzy interpretation triangle. So I will explain later. So with a rectangular shape, they proposed by Atanasov and Gagov in 1989. So basically, now we deal with imprecise membership degree. Okay, so instead of represented by a single value, now interval represented by interval. So just expansion of interval mathematics in the concept of intuitionistic fuzzy set. And then recently, circular intuitionistic fuzzy set was proposed by Atanasov in 2020. It is another extension of membership and non-membership interpretation into a circle. Okay, so interval value represented by rectangular. Okay, so the element of uncertainty of membership and non-membership. While circular intuitionistic fuzzy set represented by circle. So I will show you the graphical representation later. Okay, so for now, circular intuitionistic fuzzy set is characterized by three tuple, okay, membership, non-membership, and radius. Okay, so of course we still have hesitancy, but now we just represent using three tuple for the computational purpose. Okay. Okay, so the idea in this slide, I just want to mention that the expansion from Chris membership degrees to imprecise membership degrees. Okay, this is the geometrical interpretation. The first one, A, represent interval value intuitionist fuzzy set, and B, circular intuitionist fuzzy set. Okay, so this interpretation we call intuitionistic fuzzy set interpretation triangle. Okay, so Atanasov actually proposed more than 7 interpretation, but one of them is this interpretation. Okay, so you can see there we have x-axis represent membership degree and y-axis represent non-membership degree. Okay, so the line diagonal represent the complement of membership and non-membership. So meaning that this diagonal line represent the case of fuzzy set, okay, where mu plus nu complement. And the case of intuitionistic fuzzy set is in between this, meaning that inside the interpretation triangle. Okay, so in figure 1, as I mentioned before, interval value intuitionistic fuzzy set represented by a rectangular. Okay, so while B, circular intuitionistic fuzzy set that recently introduced, represented by a circle. Okay, so you can see that we have radius. So radius meaning that the greater R, the greater radius, so the greater certainty we have for membership and non-membership. Okay, so meaning that we have equidistant between the center and the boundary compared to rectangular shape in interval value intuitionistic fuzzy set. That's the main point. Okay, and okay, the main motivation for this presentation, okay, with respect to the theories that I mentioned before. So CIFS provides a better representation for modeling imprecise membership degrees, but it is limited to the space of intuitionistic fuzzy set. So meaning that in circular intuitionistic fuzzy set, we just have mu plus nu less than or equal to 1. It cannot consider the case of greater than 1. Okay. So the sum of membership and non-membership degree is bounded by 1. Okay, so this limitation actually can be overcome by expanding the existing intuitionistic fuzzy interpretation triangle area in CIFS to include larger space provided by Q-rank autopair fuzzy set. So remember I mentioned before, Q-rank autopair fuzzy set, we can consider the case that mu plus nu greater than 1. Okay, in a simple example, you can consider that the goodness and badness of a person not necessarily limited to the goodness of a person plus the badness of a person less than 1 or equal to 1. It can be greater than 1. Maybe you are good at 0.7 and maybe you are bad at maybe 0.4. So that summation 0.7, 0.4 greater than 1. Okay, so that's the case that Q-rank autopair fuzzy set can handle that problem. Okay, then we come up with the objective of the study. Okay, the purpose of this study is to define circular Q-rank autopair fuzzy set, okay, which not only can model the imprecise membership degrees, but also can cover a larger space of imprecision. Okay, so we combine circular intuitionistic fuzzy set on the one hand with Q-rank autopair fuzzy set. Okay, so to provide two features of what we have in CIFS and as well as Q-rank autopair fuzzy set. Okay, in specific, we focus on define the set form of circular Q-rank autopair fuzzy set along with the applicable relations and operations. And then we define algebraic operations. We examine several properties and then define model operators. But for the purpose of today's presentation, so maybe I just focus more on the idea behind that and as well as algebraic operation. Okay, let's look at one by one the formal mathematical definition for intuitionistic fuzzy set. Like I mentioned before, in intuitionistic fuzzy set, we consider mu and nu, where mu can be membership, also can be interpreted based on any application, validity, for example, correctness or support for, while nu represent the degree of non-membership, can be non-validity, can be interpreted as non-correctness or support against. Okay, for example, you can imagine that we have a election, for example, to vote candidate. So maybe from 100 people, so maybe 70 people vote for that person, and maybe 20 uh, vote for someone else, and another 10 maybe abstain, didn't do anything, didn't vote. Okay, so that's the idea here. So meaning that mu plus nu can be less than or equal to 1, where pi here represent the hesitancy degree or non-determinacy, where 1 minus mu minus nu. Okay, so graphically you can see uh, the figure below. Okay, and then we look at Q-rank autopair fuzzy set. Okay, so similar. So we have the same thing, mu and nu, but this time mu and nu is allowed. Mu and nu are allowed to be greater than 1. Okay, the summation of mu plus nu can be greater than 1, but we raise mu and nu to the power of q. So you can see there. Okay, so mu to the power of q plus nu to the power of q, still we can limit to the less than or equal to 1. Okay, so individually mu can be mu plus nu can be greater than 1, but when we raise mu to the power of q and nu to the power of q, still we can convert this to follow the constraint 0, 1. Okay, so where q here represent integer, positive integer greater than or equal to 1. So we know that if q equal to 1, we can get intuitionistic fuzzy set. Okay, so when q equal to 2, we can get Pythagorean fuzzy set. Okay, so in this figure. So you can see the representation space of Q-rank autopair fuzzy set. As I mentioned before, Q represent the parameterized family of intuitionistic fuzzy set. If Q equal to 1, we can convert this Q-rank autopair fuzzy set to intuitionistic fuzzy set. Okay, so we have triangle. And then for 2-rank autopair fuzzy set, we have intuitionistic fuzzy set of second type or Pythagorean fuzzy set. Okay, and for 3, we have Fermatian fuzzy set. So basically, 2, 3 actually just to deal with how we can raise to the power of something, and then it can get value less than or equal to 1. Okay, so for example, we can see here, assume AB is an intuitionistic fuzzy membership degree with AB element of 0, 1. Okay, so AB less than 1, so then we can get intuitionistic fuzzy set. But what if A plus B greater than 1? So of course, if we raise to the power of Q or power of something, so we can get less than or equal to 1. Okay, so numerical example, you can see here. Okay, so the summation of A and B, we can get 1.368, which is greater than 1, which is disobey the concept, the theory of intuitionistic fuzzy set. But if we raise to the power of 2, okay, so in this case, Pythagorean fuzzy set, okay, we can get equal to 1. Okay, so by increasing the value of Q here, so the range of acceptable orthopair space widen. So then user or decision maker or anyone can have can express membership and non-membership with greater flexibility. Okay. Okay, then we look at circular intuitionistic fuzzy set before we define circular Courant orthopair fuzzy set. Okay, so in this case, the same idea. We have membership and non-membership, mu and nu, but with addition r. So remember, r represents the radius, so the degree of the range of imprecision. Okay, so still mu and nu here in this case. Okay, so mu and nu represent the center of coordinate. Okay, so r radius. Okay, and then we can represent circular intuitionist, as I said, in this term as well. Okay, so where O here, okay, mu and nu, where mu and nu, you can see we have a Euclidean distance. So mu and nu, just the center point and the distance between the point AB. So we can see that from the Euclidean distance. So still the distance should be less than or equal to r. So should be less than or equal to r. And intersection L lattice. So meaning that still within the 0, 1 for any given r. Okay, in precise membership and non-membership. Okay, and then okay, so that was proposed by Atanasov recently in 2020, and then of course Atanasov in 2020 he defined R, okay, R element in between 0 and 1, and then we can notice here that if R element of 0 and 1, so still some part of intuitionistic fuzzy set triangular interpretation cannot cover this part. Okay, so then later on Atanasov proposed R should be square root 2. So meaning that we have the diagonal here. Okay, so Pythagorean line here. So R equal to square root 2. Okay, so then we can get for R element of 0 till square root 2, then we can cover everything in between this triangle. Okay, so meaning that if you look at, for example, maybe we can represent this circular intuitionistic fuzzy set by a group of expert. Okay, so a group of decision maker or expert. So someone maybe provide the value 1, 0, so membership 1, non-membership 0, and then maybe some other expert provide 0 and 1. Okay, and maybe some in between. So that's why we expand R to include all those what we have in this triangular region. Okay, compared to A. Okay, so based on those two theories, so we combine circular intuitionistic fuzzy set and Q-rank orthopair fuzzy set to come up with this definition 2.1, which is circular Q-rank orthopair fuzzy set. Okay, so mu and nu here can be imprecise. So then we have R, okay, and then we raise mu and nu to the power of Q, okay, to provide greater flexibility, meaning that mu plus nu can be greater than 1. Okay, so that's the main idea. So you can see here, so okay, this is the case that area boundary for Q greater than or equal to 1. Okay, so for the remark here, of course, if AB, okay, less than or equal to 1, which is intuitionistic fuzzy set, so of course, when we raise to the power of Q, okay, so of course, we can get circular Q-rank orthopair fuzzy set also satisfy this condition. Okay, so this implies that if A element of circular intuitionist fuzzy set, then also A element of circular Courant autopair fuzzy set. Okay, and then we look at relations. So maybe I just focus on this a bit. So remember we have now membership, non-membership, as well as radius to represent circular Courant autopair fuzzy set. So then we have uh, three relations for inclusion and three relations for equality. Okay, so for inequality, if A element of B, so of course membership A less than or equal to B, while non-membership should be greater than or equal to B. Okay, so the difference just if R equal to S, R less than S, and R less than S for A and B. Okay, so basically just we, instead of one, only one inclusion, A subset B, so now we can have three types of inclusion depending on mu, and then depending on radius R. So similar to equality, and we can derive already just redefine the relation operations of the existing circular intuitionist fuzzy set or Courant fuzzy set to fix with circular Courant fuzzy set. Okay, so I think the rest just based on the mathematical part, formal definition, formal theorem. So I think I will not discuss this. Just to highlight some. So for algebraic properties, so we define idempotent law, inclusion law, absorption law. Okay, and then we have model operators. Okay, and yeah. And then, so to conclude what I just presented, here I just introduced circular Courant autopair fuzzy set as a new and more flexible extension of circular intuitionist fuzzy set and Courant autopair fuzzy set. And then we presented operations relation for circular Courant autopair fuzzy set and study their properties and examine model operators. Okay, so for future, the operation over circular Courant autopair fuzzy set can be further generalized to triangular norm, triangular quanorms, and of course can be further applied. So on and so forth. Okay. Okay, these are some references if you are interested. Okay, so thank you. I think that's all.
Thank you, Dr. Benjamin. Terima kasih. Mungkin you open for Q&A, is it? Any question or comments? Kita buka sekiranya ada persoalan ataupun pertanyaan, boleh kemukakan kepada Dr. Benjamin. Mungkin
Saya dah present cuba sampaikan masa yang ditetapkan. So tak ada sangat.
ya, biasa pembentangan yang sangat menarik dan padat. So mungkin ada
Okay, any question?
buka sekiranya ada pertanyaan. Mungkin selepas ni kalau sekiranya ada mungkin bertanya di luar pada seminar ini, boleh juga terus email ataupun bertanya.
Boleh.
Mungkin nak melanjutkan apa?
Okay. So ada juga ramai yang tengah dalam festival tu, kawan-kawan yang bidang sama fuzzy set.
Ya. Okay. Mungkin tak ada soalan. Sekali lagi saya ucapkan terima kasih kepada Dr. Benjamin atas kesudian untuk membentangkan di seminar Inspem ini, dan kita doakan semoga kajian doktor ini terus maju jaya, insyaAllah. Dan tahun ini bukan tahun terakhir di Inspem ke? Macam mana?
Oh ya, sampai September je.
Ya,
Daripada Oktober
okey.
tahun lepas sampai
Mungkin ada
September. Ya.
mungkin ada beberapa bulan lagi mungkin sekiranya nak
Okay. Okay, terima
bertemu
kasih
berjumpa
banyak
dengan
Dr.
doktor, mungkin
Raizat
ada lagi ruang di
and
sini,
everyone who
insyaAllah.
listening.
Ya,
Okay,
ya,
insyaAllah.
terima kasih. InsyaAllah kita jumpa lagi. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay.
Bye-bye.
Assalamualaikum.
Waalaikumsalam, dokter.